Assalamualaikum semua and very good morning. So, saya nak discuss soalan extra exercise that I have given you sebelum ni. So, untuk yang silap lah especially, mari kita tengok jawapan yang betul dulu. Okay, dan betulkan dekat korang punya solution lah. So the question is the magnitude of force exerted by a person on a box is 60 Newton. So this is your external force. Okay, exerted at angle of 40 degree. Draw the free body diagram. Okay, free body diagram. Okay, so you should have one dot at the center. So before that, we need to determine what are the forces acted on our box. So we have weight, we have normal, and in this case it doesn't mention anything about friction, so we assume there is no friction. Okay, and even the word rough surface is also not mentioned, so there's no friction. Okay, so our free body diagram will be this one. So we have weight, we have force, we have normal. So every forces mesti pada kedudukan asal. You tak boleh nak sengitkan tiba-tiba nak sengitkan force external tu jadi macam ni, tak boleh. Okay, dan juga tak perlu resolve dia. You don't need to resolve. Free body diagram is all about putting the original forces. Okay, dan kalau lukis macam ni as your free body diagram, it is not accepted. Okay, so free body diagram mesti dot at the center. Okay, and then question B, it asks us to find the acceleration of the box. So logically, acceleration is going to the right. The motion is to the right. So we are dealing with only x-axis because the motion is in x-axis. Okay, so in this case, the only forces that we have in x-axis adalah, so we have this one, right? F. So we need to find forces in x-axis, maksudnya kita kena cari fx lah. So we have theta here and you have your fx here. So your fx is equal to acceleration in this direction, right? So we are going to write down our equation as summation of fx equal to ma. So fx is f cos theta is equal to ma. So f kita is 60 cos 40 equal to our mass is 20. So then you can get your A. A is 2.3 meter per second. Okay, so that is for B. For C, determine the upward force. Okay, now we are solving question C. Determine the upward force. So we want to find normal. So if you can see here, our normal force is actually at the y-axis. Okay, so as you can see at y-axis we have normal and weight. Okay, so not to forget, we have one more force, that is Fy, because our external force that we have discussed just now is actually resolve itself into Fx, x component, and also y component. So actually in y component here, we have one more contribution by other force, that is Fy. Okay, so this is for C. So we always go to the basic. If we want to solve the question for forces, so we have to write down this one, this equation. Okay, so in this case, we are talking about y-axis. So there will be no motion in y-axis, meaning Ay is equal to 0. So you can substitute here 0. And for total forces in y-axis, we have 3 forces: normal, Fy, W. So we add up all the forces based on the direction. So everything is upward is going to be positive, everything downward is going to be negative. And we want to find normal, so it's going to be the equation is going to be weight minus Fy. Okay, so our weight is mg, our Fy is f sine theta, so mass is 20, 9.81. So when you complete your calculation, you are going to have your answer as 157.3 Newton. Okay, so that is how we solve this question.